HBr reacts with this compound under anhydrous conditions at room temperature to give. Since the reaction take place under anhydrous conditions, so there is no question of bond cleavage around etheric oxygen. No bond cleavage around ether oxygen. So the reaction will be CH2 double bond CHO CH3, where this lone pair will be given here and this bond comes here, plus HBr will form CH3 CHO CH3 and Br. So option D is the correct answer. Alkyl group has maximum plus I effect. Increasing plus I effect order is CH3 thrice, tertiary, then isopropyl, which is secondary alkyl, then comes ethyl, then methyl. As the steric hindrance increases, the plus I effect increases. So option C is the correct answer. The following compound, the one that is most reactive towards electrophilic nitration is, electrophilic rate order is toluene is more reactive than benzene, which is less reactive towards benzoic acid, and the least reactive is nitrobenzene in an electrophilic nitration reaction. So option C, toluene, is most reactive. Which of the following shows exhibits geometrical isomerism? A 1, 2 dibromopropene, B 2, 3 dimethylbutene, C 2, 3 dibromobutene, D 2, 3 dibromobutene. So of all this, carbon double bond carbon Br CH3 Br CH3 shows geometrical isomerism. This is 1, 2 dibromopropene and another compound Br CH3 2, 3 dibromobutene also shows isomerism geometrical. This one is cis form and this one is also cis form. Another one is trans form, which is not in this example. So both option A and C are correct answer. The following compound may not exist as enantiomer. Enantiomers are the optically active compound which has D and L forms. For being an enantiomer, there should be a chiral center in which all the atoms attached are not same. So C6H5, CH2 and CH3. The chiral center is absent, so it is not exist as enantiomer. In ethane and cyclohexane, which of the following pair of conformation is more stable? A eclipse and chair conformation, B staggered and chair conformation, C staggered and boat conformation, D eclipse and boat conformation. So in ethane and cyclohexane, ethane has staggered form more conform, and cyclohexane has chair form more stable. In ethane, the structure will be and the chair conformation is in cyclohexane. This is the chair conformation. So option B is the correct answer. Following the optically active compound is the compound CH3CHDOH can be written as CH3COH H and D. It contains one chiral center, so this molecule is optically active and can be written in D and L form, that is dextro and levo. Option C is the correct answer. Number of optical isomer of lactic acid are, the structure of lactic acid is CH3CCOOH, hydrogen is attached here, NOH. Only one chiral center is present in lactic acid, so it will have two optical isomer. Number of optical isomer is 2 raised to n, where n is the number of chiral carbon. So here 2 is equal to 1 raised to 1 is equal to 2. Option B. Maximum number of isomer of alkene C4H8 are, one isomer is isobutene, one butene. In total there are 6 isomer. Third one is cyclobutane. Fourth is trans 2-butene, cis 2-butene, and the last one is methyl cyclopropane. So there are 6 isomers. Option D. Compound C4H10O can show, it can show position isomer as butane 1-ol and butane 2-ol. Functional isomer will be butanol and diethyl ether. Metamers will be diethyl ether and methyl propyl ether. So all of this is the correct answer. The following pair, the pair that illustrates stereoisomerism is cis 2-butene and trans butene are geometrical isomers. This is the structure of cis 2-butene and trans 2-butene. So this can be written in as stereoisomers as well. So option B is the correct answer. Functional isomerism is exhibited by which of the following compound? In functional isomer, the functional group is rearranged. So both the isomers have different functional group. So acetone and propanaldehyde show functional isomer. Here aldehyde is the functional group and here oxo or ketonic group is the functional group. So option A is the correct answer. Functional isomerism is exhibited by which of the following compound? In functional isomer, the functional group is rearranged. So both the isomers have different functional group. So acetone and propanaldehyde show functional isomer. Here aldehyde is the functional group and here oxo or ketonic group is the functional group. So option A is the correct answer. Functional isomerism is exhibited by which of the following compound? In functional isomer, the functional group is rearranged. So both the isomers have different functional group. So acetone and propanaldehyde show functional isomer. Here aldehyde is the functional group and here oxo or ketonic group is the functional group. So option A is the correct answer. Glucose and fructose are A optical isomer, B functional isomer, C position isomer, D chain isomer. Glucose has aldehydic group, fructose has oxo or ketonic group. Glucose and fructose are similar molecular formula, that is C6H12O6, but differ in functional group. So these are functional isomers. Option B. Order of stability among the three main conformation of 2-fluoroethanol is, the extent of intramolecular hydrogen bonding decides the stability. So intramolecular hydrogen bonding decides the stability sequence. So eclipsed hydrogen, fluoride hydrogen, OH hydrogen, hydrogen is more stable than gauche. Here is the hydroxyl. I am not filling the position for hydrogen, and anti is the least stable. Here is the fluoride, and here is the hydroxyl. Rest of the position are occupied by hydrogen. So option A is the correct answer. Which will give chiral molecule? The reaction of C2H5OH CHO propanaldehyde in presence CH3 MgBr H plus and H2O will give, this is a Grignard reagent reaction, will give a carbon which is chiral, as all the substituent attached are different, all four valencies attached are different groups. So option B is the correct answer. Type of isomerism observed in urea molecule is A chain, B position, C 6, D tautomerism. Urea molecule has keto form and enol form, where NH2C NH2 is the keto form and its enol form is CNH2 double bond NH2 and OH. This is enol form, so it should tautomerism. Option D. Optically active stereomers are possible for butane 2,3-diol. The structure of butane 2,3-diol is this. This one is chiral carbon and this one is chiral. Number of asymmetric or chiral carbon is 2. Therefore, number of optical isomer possible is 2 raised to n. 2 raised to 2 is equal to 4. Number of optically active stereomers is equal to 4 minus 1 is equal to 3, because meso compound is optically inactive due to internal compensation. So option A is the correct answer. The maximum bond energy of CH bond is found in the compound A ethane, B ethene, C ethine, D equal in all the three. So the bond energy to break the bond is maximum in ethine, because ethine or acetylene has triple bond. This bond becomes stronger as it becomes shorter. It consists of 1 sigma and 2 pi bonds. So there is more localization, delocalization and resonating structure, shorter the bond length and difficult to break. So option C is the correct answer. General organic chemistry. In the hydrocarbon CH3CH double bond CH, single bond CH2, single bond carbon and triple bond CH. The state of hybridization of carbon 135 are in the following sequence. So for this particular question, the carbon are numbered from 1 to 3, 4, 5. When there is a single bond, it is always denoted as sigma bond. Two bond, one is denoted as sigma and one is pi. And when our three bonds are present, one is sigma and 2 pi are present. So this will lead to sp hybridization, sp2, sp3 hybridization. So carbon 1, 3 and 5 have sp, sp3 and sp2 hybridization respectively. Option D is the correct answer. Which of the following is an electrophile? A H2O, B SO3, C NH3, D ROR. Water, ammonia and ROR, which is ether, are nucleophiles. Water, ammonia and ROR are nucleophiles. SO3 has electron deficient center, reagent which can accept an electron pair in the reaction. So SO3 does not have its octet completely filled. It is 2 electron deficient. That's why oxidation number of sulfur is +2. Therefore option B is the correct answer. Reaction of HCl to vinyl chloride gives 1,1 dichloroethane because of A. Mesomeric effect of chloride, B. Inductive effect of chloride, C. Restrictive rotation around double bond, D. None of this. A reaction of vinyl chloride BCH CH2 double bond and chlorine plus HCl will give CH3, CH and dichloroethane. It is an addition reaction. It is formed according to Markovnikov's rule. So option D is the correct answer. Which of the following compounds show optical isomerism? A. Tertiary butyl amine, B. Secondary butyl amine, C. Isobutyl, D. N-butyl, Ne neopentyl amine. To exhibit optical isomerism, the compound must have a chiral center in which all the atoms attached are different. So, secondary amine has two different alkyl groups directly attached to the nitrogen atom, which is NHC3H7CH3. So this is a secondary amine. So option B is the correct answer. Which of the following acid does not show optical isomerism? A. Malic acid, B. Alpha amino acid, C. Lactic acid, D. Tartaric acid. The structure of malic acid is carbon double bond carbon H COOH and COOH. It shows geometrical isomerism but does not show optical isomerism because it does not have a chiral center. Rest other atoms have a chiral center, so they show optical isomerism. Option A is the correct answer. One reaction is faster in SN1 mechanism proceed through carbocation intermediate. So the structure this is a tertiary chloride provides stable carbocation intermediate because it is a tertiary carbon atom and the stability of carbocation is tertiary to secondary to primary. So option C is the correct answer. Among the following, the dissociation constant is highest for dissociation of proton from CH3 NH3 plus Cl minus is very difficult due to minus I effect of chloride and N2 N plus ion, which is nitride, while in phenol due to resonance stabilizing of phenoxide ion proton eliminate easily. Similarly, due to hydrogen bonding in C6H5 CH2OH, it can eliminate, and in the compound propanene shows acidic character by triple bond. Here is the acidic hydrogen. So because of triple bond by which proton cannot be dissociated, can be dissociated. So option D has highest dissociation constant. Compound has three chiral center atoms. The number of possible optical isomers it can have. The number of possible optical isomer is equal to 2 raised to n, where n is the number of chiral center. So here 2 raised to 3 is equal to 8. So it can have 8 chiral center. Option C. With a change in hybridization of carbon bearing the charge, the stability of carbon ion increases in the order. The stability of carbon ion increases with increase in s character of hybrid orbital of carbon bearing charge. Hence the correct order is sp3, which is least, then sp2, then sp hybridization. For carbocation it is sp3, sp2 and sp. So the correct answer is option C. Which of the following compound will show metamerism? Of the following, the diethyl thioether C2H5S, C2H5S, this is dimethyl thioether and methyl propyl thioether are the two metameric forms of this compound. So here it shows a metamerism, option B.